Caddis Maximus here, this time with a riveting review and comparison of heavy-duty manual hand riveters. I also included a couple of Molly bolt pullers because they seem to be the most similar, and it was easiest to fit them into this review. Even though I couldn't find a single Molly bolt to use with one of these tools, they're real simple and straightforward in operation. And a lot of times they look the most like what a riveter might look like. And what Molly bolt pullers are is they're actually for known as drywall anchors. So you have the gypsum board, the fire-resistant board inside residential and office buildings. And a lot of times you want to mount something to them, but drywall is a very weak and brittle material, so you can't just put a big screw into them because it just won't hold very well. So what you have is Molly bolts, which are considered the heavy-duty version of a mount to screw something into drywall because it has a wide surface area. Now, many alternatives for drywall are either little plastic inserts that just offset the load to a slightly larger hole. Then there are these, which are real common, and I kind of like these. You just use a Phillips head screwdriver, and they drill and screw themselves into the drywall. And when they get into the drywall, they have this real thick, heavy-duty thread. Or I should say very deep cut and oversized thread just to offset the load into the drywall. And then you screw whatever you need to attach right into the center of it. Some of the criticisms of these is when you unscrew, sometimes the screw gets stuck and this whole apparatus unscrews out of the drywall. And they're difficult to patch over because they leave a much larger hole, but these things do work pretty well. They do have a good gripping force. Now, a Molly bolt is even a heavier duty version of that. What it is, it's like a screw and kind of like a rivet. And what I mean is there's a screw and then they have this strange looking sheet metal collar where the screw is actually threaded into the bottom of the collar. And it's a collar that would kind of be similar to what's on a rivet, something more like this. And it would just be this long collar with these three kind of bent sheet metal legs on it. And how it works is these pullers, you drill a larger hole. These flanges are much bigger than a rivet. They're huge, kind of like what's on this, with a couple little legs that stick down to keep it from twisting in the drywall. And then you drill a hole, you push it through, and then this is something that grabs onto the end of the bolt and presses against the end of that weird-looking kind of flange nut, and it pulls it. And as it pulls the screw head, the three little legs will expand out and compress against the back of the drywall, giving you a very wide gripping surface area. Also, they resist wanting to twist or turn when you screw things in, and they're about the most secure way of attaching something to gypsum board is Molly bolts. That was who originally came out with this. This is just a simple nylon Molly bolt puller, which works okay, and they just grab and pull into the fastener. They have like a little, this is a nylon one with a little cast zinc or cast aluminum insert, and there's just a little V groove that grabs a hold of the bolt and pulls it in. And let's get that out of the way. This is kind of a cheesy Workshops brand, but what's nice is this would be considered a much heavier duty version because it's an all steel construction, and I actually like using this one quite a bit. It's a Taiwanese unit, but it still works pretty well. And this gives you a better view of how this works, where you put in the fastener, it goes into that V groove, and then as you pull, it just simply yanks the end of the bolt to expand the Molly bolt. And if it doesn't expand as tight as you'd like it to, you can always pull the tool off, screw in the fastener a little more, and then put it back into the tool and, of course, crimp it further. That was just a quick review, an overview of Molly bolt pullers. And sorry, I really looked for a Molly bolt, and I didn't really want to run over to the hardware store just to pick up a Molly bolt, but I did have plenty of rivets. So let's talk about the various forms of riveters. One of the most common ones people have seen, at least in the United States, are like these pop rivet tools. These are just a basic riveter. They're pretty simple in operation. They have just a single gripping claw, where most professional riveters with these round jaws have two half-rounded claws that grip on both sides of the rivet, where this just grips on one side. So these are just a normal, I would say, standard duty. Under heavy use, they do tend to want to slip on you. But one nice thing about them, surprisingly enough, is that they have a very high leverage ratio, so these types of tools can ratchet. So as you're drawing the rivet in, and I'll go ahead and do this rivet on this tool. which is kind of surprising. Rivets are generally pretty safe. Riveters, when they're all the way open, it releases the jaw so you can get the rivet in and out, and so you can get the post in and out. One other thing to make note of is that rivets tend to have a little bit of play just so that the nail doesn't want to get stuck. When you break the rivet nail, and I'll show that in a minute, it kind of has two little wings or two little burrs, and they kind of want to get stuck in the die, so they end up making the holes a little bit oversized, so that doesn't want to happen. And I was using a non-standard rivet. This is what a normal rivet looks like. I have one reverse to demonstrate something. But how riveters work is you just stick them through a hole. You really want the hole to be precisely sized because they just don't have much range, and it simply just pulls the little nail, the head of the nail, through in this case it's a steel nail through aluminum, and then it just ratchets, and you just continue to perform that operation. And as you can see, as it draws that little button head through, it starts to expand the metal, and that's against this washer, and that's how rivets work. And it's cold forging the metal. It's really a secure connection, and they can be easily drilled out. Like this is a 3/16 rivet, just by taking a 3/16 drill bit and just drilling into the center of the rivet. Let's go ahead and put this away. But the pop riveters are just the basic ones, and they take, they usually have two dies, a small 1/8" die and then a larger 3/16 die. And they generally, for just random riveting, they're generally okay, but I definitely recommend one of the more heavier duty rivets. Riveters is what I should say. And continuing on that, we have what would be considered the heavy duty or more professional grade hand riveters. You can see they have a much larger handle. This is a Stanley, so we have a Stanley, we have a Elgen, and then we have a Craftsman Industrial. And so it's kind of surprising the variation of designs of what is the same tool. This Stanley has worked generally pretty well for me. It's pretty compact. It is all steel, so it's a little heavy, but it's actually been a real solid performer. Most professional grade ones will also, instead of coming with two dies, they'll come with 4 different size dies, so that you can get a closer fit with the rivet. One of the issues with rivets is if you use a rivet that is a die that is way too large, much larger than the shank of the rivet, then especially like on aluminum, it can pull some of the aluminum into the die itself, and the rivet will want to get jammed, and it's a real special situation. You have to unscrew the die to get it out. Also, it lets the shank of the rivet wobble around a lot more, and so it doesn't want to stay centered in the gripping jaws, and then they tend to slip. And so that's why they come with greater sizes, so you actually have more consistent performance. And a lot of these usually come with a little wrench integrated into them. The other nice thing is, of course, the long nose. Where a basic pop riveter, you have to be, it's flush. Where on most industrial ones, they do have a protrusion, so you can get into tighter spaces that you may want to use rivets. We do have a Craftsman Industrial, and this would be considered, this is an all-cast aluminum one. And what is surprising about this Craftsman Industrial, there it is it's missing a couple of features that I would consider would be industrially rated, and it always kind of has surprised me. One of them is most of these work pretty well, and they have a fixed setting, so when they open all the way up, it presses against the back of one of the dies, and I should point that out here. Let me take the little wrench and unscrew one of these. There we go. Sometimes they get a little tight. But on the back of the dies, there's a little chamfer, taper. And so that when the 2 fingers of the jaws, when it's in the all the way open position, press against the back of this little chamfer here, and it spreads them apart, and that's what releases the rivet. Let me go and put that back in there. But sometimes that doesn't work out so well, or sometimes you get rivets that have varying length shanks, and you do want to adjust it. Unfortunately, only one of these riveters is really adjustable, and that's the Elgen. And so that's one of the features the Craftsman is missing, is that there isn't really a way to adjust the jaw positioning or their not calibration, but their grip point. And so that kind of is a takeaway from the Craftsman. or I should say negative. When you talk, and especially when it's kind of odd because it's really bulky and it doesn't have as much reach on the nose. It works pretty well. It has a high leverage ratio. It's also missing one of the little chains to hold the handles together, so these tend to take up a bit of space. So I was always kind of disappointed with the Craftsman Industrial version of their riveters. These Elgens is what I consider to be industrial. These are a very high quality. These are forged aluminum versus the Craftsman Industrial, where it just, this line, this flashing, it really looks like it's cast. It's really pretty thin. You can see right there it's pretty thin. And when you're casting aluminum, oftentimes you can have wide flashing. That is where the area of metal that would squish out if you're forging it. But it just doesn't, and if it is forged, it just isn't as obvious and high quality such as this Elgen, where you can see they actually hammered a piece of aluminum between two dies and squashed it to align the crystalline grains. A bunch of the metal squeezed out in this really wide flashing, and then they ground it off. So that's one thing, is this is a forged aluminum. The second thing is it has a threaded adjustable backstop, so not only is it easy to disassemble and reassemble to replace the jaws or just clean it out as metal particles build up, but you can also adjust the grip point of the jaws, so that's important. There is a third factor, is all these, it's just kind of like a round pin that pulls on the back of the, what I call the draw tube, where on this, the draw tube is pushed via a lever inside and then is supported via, a drilled hole on the top and bottom. So it maintains much better alignment and really has a solid grip on the rivets. And of course, it has 4 dies. One of the other aspects, besides being forged and having a, true guided pull rod, is they have a cast, or I don't know if this lower body is forged. No, that looks cast. It's a pretty thin line. So it has a forged upper handle, but this is a cast lower. It has a cast in place steel insert. So where the dies are screwing into is into steel, not into aluminum like on the Craftsman. That would be much more industrial. Steel is going to handle a lot more cycles of you unscrewing and screwing in different dies over the years. So this Elgen would just be an example of what a true high quality manual riveter is. And this is the Elgen HP2, just so you know. And it's really one of the best manual long handle riveters I've ever run into. That isn't specialized, such as large bolt cutter 1/4 inch riveters or these. And these are a real special riveter up here. And I'll show these. These are a hand, what I understand to be a true aircraft riveter. These are hand hydraulically operated riveting tool. And as you can see, it's very compact. It has I had a few dies. I actually found this at a pawn shop, and it was $50, but I think they thought it was some Harbor Freight tool. And these actually are, when I looked online, they were pretty darn expensive. But it's an amazing riveter versus the amount of reach that you may get with a riveter like this. These are known as aircraft because they have that really long nose and that long barrel. So obviously you can get into some very tight spaces, hence aircraft. The second thing is many times you'll need to run a large rivet in a tight space. And so these are actually a whole integrated hydraulic pump with pressure release and spring return all in one unit. You can tell that how well it's built because they use bronze bushings pressed into the steel. So this pin that the handle hinges on is actually on a oil-light bronze bushing, which is something that you rarely see on a stamped sheet metal tool. And it works like other riveters, and it just has the whole hydraulic system is very compact, and it just slowly pumps up. What's really nice about this unit is it has a very long reach, but or travel, I should say, or stroke. But they kind of have to do that. One of the things to make note of riveters is many times the little nails, once they break off, here's what one of the nails looks like once it's broken off, don't really want to release out the front of the riveter. That's just part of riveting, and a lot of times it's because of the way the little jaw teeth or the jaws leave these little indentations. And so all you do is you just take another rivet and you push it in through the anvil. When the riveter is in the full open position, remember full open is what's releasing the jaws, And then one, and I forgot to mention, is that they're all through hole so that the rivet can fall out the other side. That's all why all riveters have holes in them, is for when the nails get stuck. Even this large riveter has a through hole. It's very deep, but it still has a through hole. They had to make a compromise on this hydraulic riveter, and the reason for that is they couldn't make it have a through hole for the rivet to fall through. So the jaws tend to engage further back, so that way if the riveter or the rivet nail gets caught in the die, when you release it, it pushes the rivet out by about 1/4 to 3/8 of an inch, so you can grab it with a pair of pliers. I could demonstrate that here. I don't know if it will do it on this. We'll just finish doing this. One other nice thing is this is hydraulic, so it's very easy to operate. This was one hand. There's a little pop sound. That little pop, and why they're called pop rivets, is where the nail breaks. And you can see that the nail is stuck in the end of the tool. And on this button right here is the release, and you can see it actually popped out. You can see where it wanted to push it out, but this one didn't want to get too badly stuck, and there we have it. Of course, the one disadvantage of a hydraulic riveter is this thing always is leaking, and it's kind of fussy to add oil to it, but it's just amazing. It's really the go-to style of riveter for me, especially when they had a nice intelligent design where you push on the back handle, which initially seems like it's worse ergonomics, but it's better because when you're riveting, you want to keep the rivet tight as you're running the tool, so you're actually pressing in against the riveting surface when you're operating this, and that's actually quite smart. Also, you don't have this front handle swinging and banging into anything when you're operating the tool. And so this riveter is amazing because you can be around a blind corner and actually reach around, get the rivet into the hole, and rivet without even being able to see what you're doing. And you can rivet in very compact spaces. So if there's anybody watching who's really wondering what would be a fantastic, true professional grade riveter that you could drive, not just aluminum rivets, but also steel rivets and many other things, many other materials, I should say. The hydraulic riveters are really some of the very best that you can get. You just get incredible reach, huge amounts of power, all in a riveter that's much more compact than any of these up here. That's really pretty surprising. I guess actually the distance from the tip to the back edge of the handle when it's open is actually pretty close to both of these, except for there's no way you'd be driving 1/4 inch rivets with one of these tools. You'd break them, where this would have no problem doing it. And that's kind of the big example, is to drive very large rivets. You have these bolt cutter style riveters, and this hydraulic one's rated for the same capacity. Now, if we compare it to the bolt cutter style, it's much more compact. That's not to say that when you have a large die in there, that you won't have to put a lot more force than these smaller 3/16 ones. So finally, we have a bolt cutter style, and this is actually one that worked out very well for me. If we can get this zoomed in, we can see we have an Astro pneumatic. Now, Harbor Freight hasn't, I think this Astro's actually knockoff, but Harbor Freight has these, but they haven't worked very well, and I actually bought a set and returned them many years ago because they just seem to want to slip, where these Astros really have worked out great, and they have this double compound action. So in the open position, it opens up the jaw, and then when you close the handle, that's what's pushing that back and thus pulling the rivet. These are also adjustable because this collar or this nose piece here threads into the body, and then it has a large 32mm jam nut. And so you can loosen the jam nut and adjust this collar in and out to adjust the bite point to wherever you like it. But just to show what a huge and large heavy-duty riveters look like, that these are definitely them. Harbor Freight has them, but they just have the one set that I got just didn't seem to work very well because the jaws is for some reason must have been misformed, and I just didn't really want to deal with another one. And within a couple of weeks, I ended up finding this, I think actually at a thrift store. It's pretty amazing. The other thing to point out is these riveters are all sized for fractional or imperial rivets. And most rivets, like these Harbor Freights that I have right here, and we'll include this as also be a comparison of Harbor Freight rivets versus true high quality rivets. is that they're all sold by fractional sizes. Now, these Harbor Freights are advertised as 3/16 diameter hole by a 1/2 inch long, and that's how they're measured. Where's the normal? I have to get a normal rivet here. But that's how they're measured, is by the diameter of the hole that this shell passes through, and then how deep or how thick a piece of material. So the Harbor Freight's advertising that you can take 2 1/4-inch pieces of material, 2 6mm layers, and be able to rivet them. And it's actually false advertising flat out on these Harbor Freight rivets, and I did want to point that out. We'll get to that in a second. Because the last thing I wanted to mention about, or second to last thing I wanted to mention, is that they use different standards. So the little dies that fit in these style riveters up at the top here won't fit in the hydraulic riveter because it uses a different thread size than what these Astros are, and these are metric. So the dies between the Astros and the hydraulics, and then the ones up here, are not interchangeable, and that's something to keep note of. And it's a little bit unfortunate because it would have been nice to use the Astros dies on the hydraulic one. The reason that these Astros also have an advantage is that they're metric instead of imperial. So instead of a 3/16 die, what they're doing here is advertising die as 4 millimeters for a metric rivet. And so 3/16 is about, 4.7 millimeters. But what ends up happening, what I've really appreciated about having metric dies, is when you run a 3/16 rivet, the shank happens to fit just perfectly. And that's one thing to be aware of, is rivets, I've mentioned that earlier, is they have a little bit of play in the die so that the nail doesn't want to get jammed. But many times what I've found is I like a tight fitting die just because it keeps the rivet a little bit more under control, and you seem to get a little bit more of a solid action because it's drawing on the nail in a highly parallel fashion. And so this 4 millimeter die, as you can see on this, using this 3/16 rated rivet, just fits super tight. There's almost no play, maybe 5 or 10 thousandths of an inch, and it's really nice experience. You really can get some very even rivets. And what I wanted to point out here, we'll talk a little bit about rivets themselves and get into the Harbor Freight issues, and then I'll do a couple quick demonstrations of riveting. Okay, let's go ahead and get out some other rivets here, and we'll do a little discussion. So when you do rivet, that's what they're made for, is just taking 2 pieces of metal. If you hold them tight, then they do cinch up really tight, and that little button head draws through, expands the metal, and then you have to drill the hole very precisely. Rivets don't have much range, so you can't use a rivet where it fits loosely because it just won't cinch up anything, and it'll expand into the lower piece rather than behind the back piece that you're trying to use. You can put washers and stuff on the back as well if you want to increase their surface area. I did want to point that out. But it just draws the head of the nail in, squeezes it out, and forges that metal really tight. And that's just a great advantage to rivets. They're very lightweight. They hold securely. You can push them through blind holes and rivet something that, would be impossible to attach otherwise. And it's just a little bit of a hassle to have to drill them when you need to remove them. But they are very reliable and easy to apply. Sometimes they don't squash consistently. Sometimes they do this. Every once in a while, if you're clamping very thin material, you'll have a rivet where the nail head kind of sticks out, and that's just something you have to deal with when you're riveting thin materials, is knowing that it may not work out perfectly. And I was going to mention that this is an example of when you draw a rivet with these Astros with a real tight-fitting die, that it pulls the nail in a really parallel fashion, and you can get really nice, even expansion, versus the kind of more uneven expansion that you would get out of a standard riveter. And that can happen with just a slight amount of tilt on the nail. It's actually pretty surprising how warped those are versus how straight this one is, just by having a tight-fitting die. And just so people can see what rivets are, they're just that collar. And then here's the nail. It has a pinch spot, so it holds the collar over the end of the nail. There's the large round head that actually forges it. And then they have this area right here that's pinched. Excuse me, and that's what causes, that thins out the nail right there, and so when it snaps, that's exactly where it snaps, so it just leaves the head in there. And there is a little trick. So a standard rivet is like this, but you can tap that collar off and then reverse it and then tap it back on. That would be in a certain situation where you wanted to have the flush face of the rivet, say facing one direction, but you weren't actually able to get a riveter in there. And there would be, a few certain situations where that might be. And so you can actually reverse it where you can thread the rivet through and then pull it. And that gives you a slightly different result. There is a warning doing that on loose fitting dies. Every once in a while, some of the aluminum will get drawn into the die and the nail gets really stuck and you kind of have to hammer it out using a long nail. But one advantage of the metric ones is they're so tight fitting you don't have that issue. And when you do rivet, you can also get a different effect, which is you get the button left on the outside of the rivet versus the hole, and so you can get this really nice smooth kind of look to a rivet by having the button on the other side. One issue with doing that, of course, is since you have the button there is no hole to get a drill bit started. It's now a rounded top, and they're very difficult to remove. Usually you have to grind them off, and this is something you accept when you want to run a rivet in that direction. And if you're looking for that particularly really smooth look where you have the button head inside the rivet. And I have actually looked online and I saw some manufacturers where they actually will sell rivets that are like this. And I thought you were never really supposed to, but it's really not such a big deal to run a rivet in that direction. Okay, I got some quick measurement tools. This is the big detailed. So we're going to show the difference between the Harbor Freight rivets and their measurements versus some actual high quality professional grade rivets, and even versus some vintage ones. These are some 3/16 by 1/4 inch depth pop rivets. These are some, as we can see here, original 1976, American made high quality rivets. And I did want to put this up on the screen because they have actually a surprisingly good instructions. It's like the lost art of instructions. And it'd be nice if tools had packaging like this. Fully explains how the rivet works. It gives you some warnings about the grip range, and then even tells you a little bit about the various styles of rivets that you can find. So we'll go and compare the Harbor Freights against these. And this is the point of these measurements, is Harbor Freight clearly on their package advertises these as 1/2 inch grip rivets, and that's not going to happen. Here we are. We have the Harbor Freight rivet right here. And if we measure from the surface of that flange right out to the edge, it's right at a 1/2 inch. There's no metal to swage. How a rivet holds is because it squeezes out some metal on the back side and expands it. So I don't know how a rivet that only has a 1/2 inch collar, as we can see here, can actually rivet something that's a 1/2 inch deep. I have an actual sold as 1/2 inch rivet, and this one we can see is over 5/8, it's not even there, 675 thousandths to actually fasten something that's going to be a 1/2 inch. So if we take a 1/2 inch against this, we can see that there is going to be a sufficient amount of material for the head to fully drop in and fully expand material on the back of a 1/2 inch thick rivet. And so it's a real unfortunate. That is absolutely false. These are not 1/2 inch rivets because it is rated on how thick a material. People will buy these thinking I have 2 1/4 inch pieces and then find that they can't rivet them. The rivets just will pull out. And that oversizing is absolutely true. This is the pop rivet that I just pulled out new in the sealed package from 42 years ago. And what do we see? It's a, come on. We have a 1/4 inch rated rivet that is 425 thousandths collar on it. So there is no doubt that the Harbor Freight ones are effectively like 5/16 or 3/8 rivets. And that's actually that's a pretty big deal, to tell you the truth. People are going to buy these, but thinking, being used to rivets, or a basic understanding knowing about the diameter of the hole and then how thick a material that they can rivet by these, and then just not be able to do the project that they want to do. It's really kind of unfortunate. So to kind of continue this comparison, I'm going to do a quick rivet. I have a couple metal plates here that have a very precise 3/16 hole, so it's going to be perfect. And I'll just go ahead and use the hydraulic one. And we'll compare the rivet quality. The aluminum is much better on these. And then it sticks the rivet out. That has been pretty consistent for doing that. Now, the Astros actually work super well, so we'll go ahead and use those. The rivets, when they are properly done, these pieces of metal are very difficult to even twist and rotate. That is really a high quality rivet right there. The aluminum is much higher quality. There, we can get that in there. We'll go ahead and do these Astros. Always want to have some pressure, because if you end up getting the washer head off the surface and the rivet doesn't want to hold tight, but the Astros, and they just ratchet down. The Astros seem to always hold the rivets because of that tight die, but as you rivet, it just drives them out of the back. So here we can compare the Harbor Freight riveting compared to the American-made pop rivets, and then the professional grade true 1/2 inchers. And you can just see how much higher quality the aluminum is on those rivets. You can see that they just don't have as much modeling where it's like the surface is starting to crack. You can also see from here that the wall thickness is much thicker on these professional grade rivets than it is on the Harbor Freight. It's almost like the Harbor Freights are recycled aluminum cans, where these are actually, virgin or, high quality aluminum. And you can see where with the Astro, since I had this against the surface, that the rivet, I didn't have the pieces of metal held tight against the edge of the rivet. And that's something you want to not do, because that introduces the ability for the rivet to get loose. You really want to try to get them tight. If I can get this camera to focus, just like it is here. And on one final tip, I'll even do a demonstration of this. This through rivet, is you do want rivets to fit tightly. So if you have a situation where you have one hole that's a bit loose, and that amount of looseness would be right at the limits, and you have another hole that's tight, you want to have that on the back side where it's expanding. So in this case, we wanted to attach both of these. I put the washer side through the side that has the bigger hole, and then on the tighter side I would have the actual expanding portion. And we'll just use these Astros again. Actually, we'll make it easier. Maybe use the hydraulics. And then this will also demonstrate that little button. And it can be difficult sometimes to hold it when especially when you're doing the through rivet, but you just want to try to hold it tight. You can see where when you do that, even with a normal die, you can see where the aluminum wants to squeeze in between the nail and the die. So doing the reverse rivets really is for the realm of something like this Astro, where you have just a super tight fitting die so that the nail doesn't have an opportunity to move around like that. Or excuse me, there isn't the gap. But you can see that it still rivets just fine when you use that method, just because they all use hardened steel jaws. A lot of times you get a little bit of extra squish. You can see that I have a really thick bulge, and it's one advantage to that is you can get a thicker bulge using that method. And then of course we now have this rivet here, which actually looks really nice because it has the little round peg still on the top of the rivet, so it just gives you that really nice finish. Anyway, that was the end of a quite robust and detailed reviews about rivets and riveters, but it's something I've been wanting to do for a while, and And I've just run into so many things that have been riveted where it's just horrible riveting jobs or very loose fitting rivets, and just wanted to, give some people some pointers and comparisons on really a good way to rivet and easy and proper riveting tools to use. Once again, I really appreciate everybody watching, and please subscribe. Catus Maximus out.